Welcome back, friends, to what I'm calling lesson 4 of our probability unit. Now, this one is on theoretical probability. I told you when we were doing the experimental that we would do another lesson on theoretical probability. Now, theoretical probability is just that. It's based on theory and you're making predictions, but you haven't actually executed any experiment at all. You're just using mathematical calculations to help you calculate probability. So I'm just reminding you of what we did in the previous unit. So when we were figuring out probability, you're taking that numerator, which is the number of times that you should get something over the possible number of outcomes, and then that is your actual denominator. And that's why you call it theoretical probability, because that the number of times that you should be getting something, again, is just based on theory. And I'll show you what I mean when we go through an example and make sense a little bit more. So in this experiment here, I have 20 counters that I put into a bag. 7 green, 6 black, 5 orange, and 2 purple. Now in this experiment, you were to take one of those counters without looking and then keeping track of what you're going to do. Now I'm asking you to actually calculate what your probability is. So I'm going to jump down actually to this part here. I want to draw your attention to this. So if I want the probability of picking a black counter, I'm going to, first of all, I want to use fraction form. So always start with that one. It's the easiest place to begin from. So my denominator will be 20. That's the number of counters that we have in the bag to begin with. Now, out of those 20, 6 of them are black. So if we're talking about the probability of picking a black from that bag, you're going to have the fraction 6 over 20. Now, I want you to go a step further and convert that over to a decimal. That's important. And that's where I get the 3/10 from. So again, your numerator, divide that by your denominator. All right. And that goes back to the first lesson that you will have already done, converting your fractions over into your decimal. If you need to get your calculator, by all means, go ahead and grab it. If you're able to do that with some mental math, because these fractions are easy enough, then go ahead and do that too. Now I'm going to go over to the second example here. Suppose I want the probability of getting green. Again, my denominator will be 20. My numerator will be 7 because there were 7 counters put in that bag. So I take my numerator, divide that by my denominator, and I'm ending up with 35 hundredths. And that's my probability that I will actually be pulling green from the bag. Now, I'm going to take this a step further. Now, let's just say I ask you, now I want you to predict for me how many times you're going to pull a black counter. And let's say I tell you, I want you to do this experiment 54 times. And I want you to predict for me how many times you're going to get black. Well, again, this is called theoretical probability. So we can do this. It just requires you to go back and take your initial probability that you came up over here. So how many times, if I was to do the experiment 1 time, then I would have a 3/10 of a chance of getting black. So that's where this number here has come into play. So again, I told you I needed a decimal, and that's what it's here. And I'm going to multiply it by 54 because that's the number of times that you're actually executing this experiment. So when I go 54, multiply that by 3/10, I get, now you're going to get precisely 16 and 2/10. And we know it's impossible to get 2/10 with this experiment. So what I would do, I would round down a little bit, and I would say you're going to get a black counter about 16 times. And I've spoken on previous units about that word about, especially when you're doing some rounding. In this case, we're rounding down. Now let's go through an example here, and we'll be able to put everything into play here that we've done. Now suppose you rolled a number cube, or we're going to call a dice 100 times. I want you to predict how many times 1 will show up, how many times 5 will show up? How many times will the number that you roll, a 1 or a 5, will show, or a 1 or a 5 will not show? So let's go through my first example. And again, if you can understand this, you can answer all of the questions that we've gone through. Now, the probability of rolling a 1 is 1 over 6. 6 standing for the number of possibilities on a die, and 1 standing for, we all know there's only one 1 on that dice. So I have 1 over 6. Now it's asking us to actually predict how many times you would get it if you were to roll, if you were to do 100 times. So I've created almost like a little bit of an equation here. So 1/6 multiplied by 100, I have a fraction, and then I would get approximately 17. Now I have things here which, if I would probably tell you, this might make a little bit more sense because it goes along with what you were doing in the actual experimental probability. If you take the 1/6 and actually convert it over to a decimal, you're going to get 16 hundredths. And then from there, multiply it by 100 and you'll get approximately 17. If I were you, I would be converting over to a decimal because it's something that you're already familiar with. Some people can go ahead and multiply by these fractions and create a 100 over 6 and do it that way. You're fine, but this is a little bit more closer to what it is that you have been doing. Let's go on to B. B is asking you the probability that a 5 is going to show. So again, the same sort of fraction is going to show 1 over 6. And again, this would be the same sort of thing that if I were you, I would be converting it over to a decimal. And again, I would get that 16 hundredths, and then I would multiply that by 100, and then you would get approximately 17, okay? Because when you actually go in and do it, it actually turns out to be 1/6, and it's not, and it continues on if you were to grab a calculator. All right, I just rounded up a little bit. Now, C is asking you, what is the probability that you are going to roll a 1 or a 5? So this fraction is a little bit different in the sense that you're going to have, your 6 is going to be your numerator, but your 2 is going to be, 6 is your denominator, 2 is your numerator, because there's 2 possible outcomes that you can get. And in this case, I did reduce to 1/3 because 2/6 is a fraction that I can redo. So I did go ahead and do this. Does it matter? Do I have to? No, you don't. Because you could easily take that 2/6 or even 1/3 and convert it to a decimal. You should be doing that anyways. Okay, and if you do that, you know you're going to get decimal 333, and it's going to keep on going. So now this experiment is happening 100 times. So you would take this and then you would multiply it by 100 and you would get the answer of approximately 33. And again, that's why you have the special symbol here to show that you're going to get it approximately 33 times. It doesn't mean that you're going to get it exactly. It just means you could be a little bit lower or a little bit higher than that 33. Okay, now D is asking you, what's the probability that a 1 or a 5 will not show? So then that's when you have to worry about 2, 3, 4, or 6. What are your probability of getting those? And you know those are 4 different probabilities. So my fraction I'm going to have is 4/6. When I reduce it, I can reduce it to 2/3. And then once I sit there and actually turn around, I multiply that by 100, which is the number of times you're doing it, I'm going to get approximately 67 times. And this over here shows that if you were to take, here's where C and D are kind of a little bit unique in the sense that if you were to take your answer from C and D and add them together, you'll get about 100, which is the number of times that you're doing this experiment. So that's the answer to this one down here if you were looking at it. Okay, now I'm going to hit my last slide here. And my message to you is this, that what I just went through was a theoretical probability, meaning that there's going to be this gap between experimental probability and theoretical probability. So the number of times that you actually do an experiment, then it gets you closer to what you would have actually predicted with your theoretical probability. All right, you don't really need to do anything with this one, but you just keep it in the back of your head for the future. So there you go. There's all your lessons for me anyways on probability. My class is going to be getting a little assignment to kind of wrap all of this up. But the rest of you, those were your 3 lessons on probability. So if you need to see this lesson again, by all means, go ahead and do so. If not, we'll see you in the next series. See ya.